Welcome to the pre-calculus video for skill number 16. I can recognize and sketch parent functions. And featured below is a photo of the North Pole, or what formerly was the North Pole. As we may or may not know, a compass points to magnetic north, whereas geographic north is located at a different location. And in fact, the magnetic North Pole has a variance that changes throughout the day and throughout the year. The trivia question for the day, for the video, is how much variance does magnetic North Pole have over the course of its moving time? Alright, I've split the 15 parent functions into two categories. The first category is Lippmann's toolkit functions. These are commonly referred to by our textbook author, Lippmann and Rasmussen, as his toolkit functions. So there's 9 of those, and then I'll cover the other 6 after that. We have the first equation, the constant function, which is just a horizontal line at a value of c, and the equation is y equals c. For the skill test, you will be given either the graph, the name, or the equation, and you have to generate the other two. This extra information about domain and range will come into being with a different skill, but I've written it down here so that we can also talk about it in this video. The domain in this case is, oh, I got those backwards. The domain, let's scratch those out. Domain is all real numbers, and the range is just the constant. For the next function, we have the identity function, y equals x, and the domain and range are both all real numbers. The third function is the absolute value function, and the graph is shown there. The domain is all real numbers, and then the range is y is greater than or equal to 0. Our next function is the quadratic function, which is y equals x squared, and for this our domain is all real numbers, but our range is limited to y is greater than or equal to 0.
Cool guy!
Our next toolkit function is the cubic function, which is y equals x cubed, and our domain is all real numbers, and our range is all real numbers. Next toolkit function is the square root function, which starts at the origin and kind of curves upward and outward, so we can see that the domain is x is greater than 0 and our range is y is greater than 0. Then we have the cube root function, which has a domain of all real numbers and range of all real numbers. Then we have the reciprocal function, and the reciprocal function has a horizontal asymptote at 0 and a vertical asymptote at 0. And that means the domain is x does not equal 0 and the range is y does not equal 0. If we square that function, we have what's called the reciprocal squared function, which looks very similar except for the left half is flipped over, and technically the curve that it makes here is a little bit tighter than the reciprocal one. But for the domain, what we have is x cannot be 0, because we also have a vertical asymptote there, and for the range we have the horizontal asymptote, so the range is y is greater than 0. Alright, so that's Lippmann and Rasmussen's toolkit function. Of all of these, I would consider the reciprocal squared the least important one to remember. The other ones we will definitely use throughout the year. The cube root function is probably the next least important. The rest of them definitely you should know because they will pop up throughout the year. Make sure to have units dedicated to them. In addition to Lippmann's toolkit functions, we should also be familiar with other parent functions described below. We have the exponential function, which has a domain of all real numbers, and then the range is y is greater than 0. The exponential crosses the y-axis at 1 and has a horizontal asymptote at 0. We'll have a chapter dedicated to exponential, or rather exponential and logarithmic functions. So the logarithmic function is the inverse of the exponential. And what we have here is a vertical asymptote at 0, giving us a domain of x is greater than 0 and a range of all real numbers. And similarly, we cross the x-axis at 1. Then we have the sine function and cosine function, and the last term of the year will be dedicated to trig functions like these. A sine function is periodic, and it just keeps repeating up and down forever. So the domain for that is all real numbers because it goes forever. However, the range is limited from -1 is less than y, less than or equal to y is less than or equal to 1. So we're trapped between those two boundaries. The same thing happens with our cosine function. We're trapped between the two boundaries of +1 and -1, and it does move up and down periodically, much like the sine function. The only difference is it starts at the top, whereas the sine function starts at the origin. We'll return to these later on in the year and get pretty stellar graphing these two. And the last two functions are the least important, that's why I put them at the end. Well, I claim them to be unimportant. They're actually very important functions. We just don't deal with them much at the pre-calculus level. We have the greatest integer function, which is a step function, and for this the domain is all real numbers. You see all the x values are accounted for, but the range is just the integers. So, and then finally we have a logistic function, which actually has a really complicated equation. But the logistic equation has a horizontal asymptote at 0 and a horizontal asymptote at 1, and then it crosses midway between and is kind of pinned between those two. This is great for modeling population growth in a confined setting, such as fish in a lake. You can have 0 fish, or you could have 100 fish. You can't go above 100 because there's not enough room for the fish. We won't deal much with this, but we'll come back to it in calculus. Alright, thanks for watching video number 16. And the answer to the trivia question is the magnetic North Pole moves around the geographic North Pole with a variance of approximately 20 miles. And that's a very erratic behavior. We generally compensate for it very minimally with our compasses, but one way that we adjust for compensation of that is setting the declination based on where we are using our compass on Earth. The South Pole has no variation. It is very static. So when you're using a compass in the southern hemisphere, your south pointing compass always points exactly to the right location.